lesson where you look at perfect squares and factoring. At the end of the lesson, you'll be able to solve equations using perfect squares. So remember when we have repeating factors, that really just means one solution. So if we have x minus 4 squared, that means x minus 4 times x minus 4. If you set them both to 0, you're going to get 4. So your solution does not need to be 4 and 4. It just is 4. Square root property, remember, is the inverse of squared. So when you have a number that you find the square root of, it's actually one positive and one negative number. So we usually write it in braces, plus or minus the number. Remember our factoring options. You know, you should always look for your GCF. If there's 4 terms, go factor by grouping. If there's 3 terms, look for your product and sum. If your A is greater than 1, you're going to have to use the multiply A and C. If you only have 2 terms, look for a difference of squares. And then check for perfect square trinomials. Just maybe you can get a shortcut. All right, so here's one with repeated factors. Let's make sure that this is a perfect square trinomial. Perfect square, yes. Perfect square, yes. 2 times the square root of the first one times the square root of the second one. 2 times 1 times 11 is 22. So it is a perfect square trinomial. So this becomes x. Here's plus 11 squared equals 0. So if I set them to both to 0, so that really means x plus 11 times x plus 11. Set it to 0, x plus 11 equals 0. So x equals negative 11. This one, x plus 11 equals 0, so x equals negative 11. So my answer is negative 11. In B, of course, we've got that fraction, so we want to get rid of that. So we'll multiply everything by 4, and that would get us 4x squared minus 4x minus 1 equals 0. Is it a perfect square trinomial? Perfect square, 4x squared, yes. Negative 1, yes. Middle term, 2 times the square root of 4 times the square root of 1. So yes. So our answer is 2x minus 1 squared. So we're going to set that to 0. 2x minus 1 equals 0. Add 1 to both sides, and we get 2x equals 1. So x is equal to 1/2. We don't have to do it twice because the factors are the same. So 1/2. On the third one, I have to make it equal to 0. So the first thing I have to do is add 8 to both sides. And that gets me 4x squared plus 12x plus 9. Perfect square, yes. Perfect square, yes. Middle term, 2 times the square root of the first term times the square root of the second term, 3. So 2 times 2 is 4 times 3 is 12. So yes, it's a perfect square trinomial. So 2x plus square root of 9 is 3 squared, which means 2x plus 3 times 2x plus 3. So set it equal to 0. 2x equals negative 3. X equals negative 3/2. So my solution is negative 3/2. All right, solve. And we're going to use the difference of squares and the square root property. So we notice that a squared minus 84 is the difference of squares. So that means this must be a plus 8 and a minus 8. Set them both to 0. So a plus 8 equals 0. So a is negative 8. And a minus 8 equals 0. So a equals 8. So my answer is plus or minus 8. If I do the same thing using the square root property, I would first have to change and make it so that 64 is on the other side. So a squared equals 64. It did say, I'm just going to go back up here, a squared minus 64 equals 0. So all I've done is add 64 to both sides. Then I take the square root of both sides, and I get a equals plus or minus 8. So that's my solution, plus minus 8. All right, we're solving. So this is already, this number right here is squared. I don't know what a is, but when I subtract 7 and then square it, so to take the square root of a number that's squared, it would just be a minus 7 equals plus or minus 5. So I need to break that into two equations. A minus 7 equals 5, and a minus 7 equals negative 5. Add 7 to both sides, and I get a is equal to 12. Add 7 to both sides, and I get a is equal to 2. So those are my solutions, 2 and 12. Okay, let's try another one. Again, a plus 3 is squared, so if I take the square root of it, I just get a plus 3. I take the square root of 16, I get plus or minus 4. Two equations, a plus 3 equals 4, and a plus 3 equals negative 4. Subtract 3 from both sides, I get a is equal to 1. Subtract 3 from both sides, and I get a is equal to negative 7. So my solution is negative 7 or 1. All right, let's solve again. So we're going to ask, is this a perfect square trinomial? It says factor using perfect square trinomial and then the square root property. Perfect square, yes. Perfect square, yes. Middle term, 2 times the square root of the first term times the square root of the second term. 2 times 1 times 2 is 4. So this will be x. The minus comes from here. 2 squared equals 9. Take the square root of both sides, and I get x minus 2 equals plus or minus 9. Oops, plus or minus 3. So x minus 2 equals 3, and x minus 2 equals negative 3. I add 2 to both sides, and I get x is equal to 5. Add 2 to both sides, and I get x is equal to negative 1. So my solution is negative 1 and 5. Okay, let's try the second one. Some more room here. So, perfect square trinomial, yes, yes. Middle term, 2 times the square root of the first term times the square root of the second term. 2 times 2 times 4 times 3 is 12. So this becomes 2x, 3 plus, from here, squared equals 36. Take the square root of both sides, and I get 2x plus 3 equals plus or minus 6. 2x plus 3 equals 6. 2x minus, plus 3 equals negative 6. Subtract 3 from both sides. I get 2x equals 3. Divide both sides by 2, and I get x equals 3 halves. Subtract 3 from both sides. I get 2x equals negative 9. Divide by 2, I get negative 9 halves. So my solution is negative 9 halves and 3 halves. Okay, so this time we're going to take the square root, but you've noticed that that is not a perfect square. So I get m minus 4 equals the square root of 3. We are not going to change that into a decimal, but I am going to add 4 to both sides, and I get m equals 4 plus or minus the square root of 3. And you're just going to leave it like that. All right, so for this one, perfect square, yes. Perfect square, yes. Middle term, 2 times the square root of the first one times the square root of the second one is 2. So it's perfect square. So k plus 1 squared equals 7. Square root of both sides. So I get k minus, it's plus 1 equals plus or minus the square root of 7. I'm going to subtract 1 from both sides, and I get k is equal to negative 1 plus or minus the square root of 7. The Tower of Terror at Disney is a free fall ride that can be modeled by the equation. The height of the ramp is h is in feet, and the time t is in seconds, and s is the starting height. Approximately how long will riders be in a free fall if their starting height is 400 feet above the exit ramp? Okay, so the h is going to be 0, and our s is the 400. That's our starting. So I have 0 equals negative 16t squared plus 400. So I'm going to subtract 400 from both sides. This is just one way of solving this equation. So negative 400 equals negative 16t squared. Divide both sides by negative 16, and I get 25 equals t squared. Take the square root of both sides, and t is equal to plus or minus 5 seconds. And since negative 5 is not a reasonable amount of time, the answer has to be 5 seconds. If a number is a perfect square, it will have how many solutions? 2, one positive, one negative. If one side of the equation is a perfect square, what can we use to solve? Square root property.